Hi, this is Professor Stucard, and in this video we're going to talk about what's known as vectorized control flow. So in this video we're going to discuss first of all what it means to be vectorized in the context of the R programming language and why that is so valuable and why it makes R such a valuable programming language, especially for data science. And then I also want to talk about functions we can use to apply conditional statements on entire columns of data. So let's start with the idea of being vectorized. So the term vector is actually used in a bunch of different disciplines, particularly math, computer science, even graphic design. The word vector shows up everywhere. Now in R, if you remember, vector refers to a list where every element has the same exact data type, or we say the data is homogeneous. And we talked about having atomic vectors, right? Vectors that only have that one particular data type. Then our data frames are built from collections of vectors, which means every column is its own vector, which means every column only has one data type. And we're going to see why that is so incredibly powerful once we start creating control flow for our different programs using our data frames. So our conditional operators, well, again, we've kind of talked about those before, but a lot of times when we have a set of data, we want to apply our conditional operator on an entire column in our data frame. That means we pick a particular column and we want to go through every observation one by one and run that conditional operator and see what's going on. And that is where the true value of the R programming language really comes into play. Because since everything is stored as a vector, we already know that it all has the same data type, which means we're going to be able to apply our conditional operator to everything without any issue. So the idea is that we usually use these things when we have a data frame. We want to evaluate one of the variables and then give that particular observation some sort of value in a new column based upon our observations. So again, we're going to go through an example in just a second, but think about it like if you were sorting colleges and you had the number of students enrolled in each college. Well, that's useful, but maybe you want to break it down to the small colleges, the mid colleges, and the large colleges. And again, what's really nice is with one line of code, we're going to be able to create a brand new column in our data frame that has that information for us. The way we're going to do that is with our if-else statements. And so our if_else allows us to evaluate a conditional statement for every value in a specified column. Basically what we're doing is we are vectorizing the if statement. So the if statement exists in every single programming language everywhere. That's a fundamental aspect of doing computer science, is the if statement. Again, R lets us vectorize the if statement to apply it to an entire column. Now, in the context that we've talked about it so far, and in most of the contexts you're going to use it, we're going to actually use it in conjunction with our mutate function. And remember, our mutate function creates our brand new column for us. So we're going to create a new column and then use our if-else statements to create conditions for how we fill in our new column. So our if-else statements, we need 3 arguments, which means we basically need to plug in 3 things. First, we need our comparison operator that evaluates either true or false. So we need to know whether our statement is going to be true or false. And then if that value is true, there has to be some value that the new column is going to take on for that particular observation. And if it's false, well, then there needs to be a value that that column takes on for that particular observation as well. So let's take a look at an example. Let's say I have a data frame with a column called prob that represents the probability of an event. So we have a very simple data frame here. There's 3 different events, A, B, and C, and they each have a different probability associated with that particular event. Let's say I want to have a new column that's going to tell me whether the event is likely to occur, which means it has a probability of more than a half. All right? Because again, we can look at the numbers, and obviously the numbers are data and they're valid, but sometimes just looking at a huge table of numbers is not particularly useful. So again, we're going to create a new column that's going to tell me whether or not the event is likely or unlikely. And to do that, we need our if-else statement. So let's take a look at how that would actually look? So first of all, we take our data frame and we want to pipe it into the mutate function because, again, that's the overall goal is I want my new column. So because I want a new column, I need to use my mutate function. So we take my data, I pipe it into mutate, and then the next thing I need to fill out is, well, I need my new column name, right? That's how the mutate function works, is that the first thing that we type in should be our new column name. And now what we're going to do after that is include our if-else function. All right, we have our if-else function that has our conditional statement. So remember, there needs to be 3 arguments in our if-else statement. The first being our conditional statement. So in this case, I want it to run through my data frame, run through that column, and evaluate, okay, is that probability greater than a half? That's my conditional statement. So then there's a comma, right? Because again, there's the 3 arguments. So it's comma, and then I need my 2 options. Well, if it evaluates to true, I want my column to say likely. And if it evaluates to false, I want my column to say that it is unlikely. I want those to be my 2 values. Now, if I run my code, and again, notice how, again, both of those are separated with commas, and also pay attention to make sure that the parentheses match at the end. So we need one set of parentheses for our if-else, and then another set of parentheses for our mutate to make sure everything kind of closes up right. But now I can run my code, and look at that. I have a 3rd column now that's called occur, right? And if I go through, well, my first event had a probability of 0.248. Well, that's less than a half, so it evaluated to false, which means my column is now given the value unlikely. Event B had a probability of 0.865, so okay, that's going to evaluate to true because it's bigger than a half, so now that column entry becomes likely, and similarly for 0.02, that evaluates to false, so we get unlikely. And that is how our if-else function works in the R programming language. Now, what if I want more options than just true or false? What if I need a branching statement that basically gives me more than just those 2 options? Well, if I want more than just 2 options, we use our case when function. All right. And again, it works very similar to our else if. Again, it is a vectorized function, which means we can apply it to an entire vector or an entire column in our data frame, either one. And what I want to do is, well, create more than just 2 categories. So let's say in this last example, I still want my categories for likely and unlikely, but in this case, if I have something where my probability is less than 0.05, meaning that the probability of it occurring is less than 5%, I want my column to say that this event is not just unlikely, but I want it to say that it is unusual. All right. So if my probability is less than 0.05, it'll be unusual. So now I have 3 options: likely, unlikely, and unusual. Here's how we're going to put that together. So again, we start with the same idea. We take my data frame. I need to pipe it into mutate because I need a new row here. I'm sorry, I need a new column here. Excuse me. So I want my new column, so I use my mutate function. Again, like before, I need to, well, come up with my new column name. Again, I'm going to call it occur. But now I'm using my case when function. So instead of the other one, again, for my branching pass, I used case when, and now I need to fill in my different probabilities. So if my probability is greater than 0.5, well, I want that to evaluate to likely, comma, and then my next condition would be if the probability is less than 0.05, I want it to evaluate to unusual. And notice in this case, I want to use the tilde. It's the shift tick mark right next to the 1. This is the syntax to use in the R programming language for the case when statement. All right. So again, we have our condition, and then we have what we want our new column to evaluate to. So we have likely and unlikely. Now, lastly, though, we need a last catch-all category. All right, because what happens if it doesn't evaluate to those 2? And again, it's going to go in order. So depending on how you set up your conditions, again, it reads it in order. And if it hits that first condition and that condition is true, it's going to do that first code and exit the whole control flow thing there. All right. So we need to make sure that, again, when we set up our conditions, that we know it's going to read it in order. And so we're just careful that we don't really overlap anything. But at the end, we do need one last statement to just kind of catch everything else. So again, we define what it means to be likely, we define what it means to be unusual, and then anything that's not either likely or unusual we want to call unlikely. And the way we set up our last catch-all category is we just say true, because true is true. So it's just going to say, okay, true is true. Here's the last thing that we do. So again, we had it kind of when we looked at the else-if statements in the previous video on just control flow. We need that last catch-all category, which used to be else. But in this case, when we're using case when, that last catch-all category, the easiest way to set it up is just to have the true. Because again, if we don't have anything, well, we won't put anything in the column, and we'll have missing data, and yeah, we don't want that. We need to make sure we have that last catch-all category. Now, when I run my code, again, I have my new 3x3 table. I have my third column for occur, and we can see that again, 0.248. It was not likely, and it was not unusual. So that last catch-all means it must be unlikely. The 0.865, well, that was greater than 5. It must be likely, so it got assigned that. And the last one, 0.02. Well, it wasn't likely, so it went to the next option. And yes, it was less than 0.05, so it became unusual. And I was able to classify everything within my case when statement. So, can you answer the following questions? First of all, what does vector mean in the R programming language? And how does that apply to data structures as well? And then what's the difference between if-else and else-if? Which I know it's a little confusing because we have if statements and else statements and if-elses and else-ifs. And again, it takes just a little bit of practice to make sure you know which one's which, and everybody can make mistakes. So don't be afraid to, in your console, question mark if-else or question mark else-if to make sure you're using the correct one. It doesn't hurt to check. And again, with these last two videos, it might be a good idea to watch them more than once to make sure that the whole concept of, well, control flow and making decisions, because again, that's what we're really talking about, is how does our program, how does our code, how does our function make decisions? Well, these are really, really important concepts as we try to build and expand upon our skill set. All right. Well, I hope this has been useful. As always, take care of yourselves.